Hello friends, this is our next project, but this time with a quadcopter. You can see that we have got a quadcopter with a KK board here, as well as we have got a Raspberry Pi kit which is now connected to an RFID reader, and this entire quadcopter is powered by a LiPo battery. This Raspberry Pi kit is now powered by our smaller, you can see that there is a power bank available inside. The smaller power bank is the one that is actually powering the Raspberry Pi kit. Now by now you could have guessed what we are trying to do. We are going to demonstrate a very useful application where we will try to track the complete warehouse through the drone along with the RFID reader whatever we have. Now you can see that we have got a RFID reader pasted, with a double-sided sticker. We have pasted it over here, and we have got Raspberry Pi board, as I have already told you. It's powered by a simple power bank unit here, and this is powered by a LiPo battery, as I have already told you. So now what we will do is we will keep this tags in different places. We will fly the drone, and the drone with the RFID reader will be capable of catching what information does this have. You know that we have a rack where we will have series of components in the warehouse, and over which every component has got an RFID tag very clearly pasted on it. This application would be very useful. For example, if there is a 5 scaled or 5 floor kind of a rack available where a human cannot easily climb and go, this application would really help you to do it easily.
Most importantly, there are robots available to do this task, but they cannot climb up and down. But we can do it with our drone to go up and down with ease. And most importantly, it avoids the manual risk. The risk of life is very high if the warehouse is tall, where we have racks which are slightly taller. If you climb through the ladder, you have all the risk of falling, and there is a chance that we make some errors there. So all those can be curtailed here so easily with our product. Now you can see that we have just initiated the process. Now the demo is going to start, where you will see how really it flies. We have got a RC control for it, and you can see that it's getting started. That's all. The reading is complete right now, and the complete data would be recorded in the cloud, which we will show you shortly.
To make sense of the data that is being read by the drone, that is the RFID data, we need to be able to give the drone the ability to push this RFID data to a database and expose this database as an API, so that any application that's developed on top of this would be able to give proper insights to the warehouse and its manager. For this, we've developed a Cassandra database and a complementing Python Flask API. So the Flask API will be running on our Intel Python distribution using the command line interface, and the key point to be noted here is that the Cassandra database has different tables connecting the RFID tags to the product descriptions. So every RFID tag will have a status associated with it, such as new or old or unread. A new status means that this is a new product that's entered the warehouse, and it's new as in the sense that it has not been read previously, and an old RFID means that it is a product that's already existing in the warehouse. An unread tag would mean that every time a drone starts reading, it has to mark all the already present tags as unread, so that if any data goes, if any of the products has gone missing, then it would, even after completing the whole read, it would still remain unread, so that we can quickly find the missing items in the warehouse. We will be using a Cassandra database to store the RFID tags that we'll be reading, and for this we will be using a Flask API to expose our database for the any application to connect to the database. So the Flask API will run on Python, Intel Python distribution, and currently we have no RFID data in our database, which can be seen through the select command. EPC is the table that will store the RFIDs and their current status, which is new or old or unread, etc. So the first endpoint that we see is an endpoint to insert IDs into the database. So when I insert a new ID, meaning a new product, it says new, and I'm inserting 3 new IDs here. When I insert the same ID again, it tells it's old because it's already been read by the drone. Now when a drone starts to read for a second time, well, let's say the next day or something, then we have to set all the IDs as 100 before we start the reading again, so that the new old process will repeat again. So now all the IDs have been marked 100, as you can see in the command line. Now after I unread, I'm trying to insert the IDs again. Now all of them turn out to be old because they're already there in the database or in the warehouse. Now after inserting a new ID, again maybe a new product might have arrived. So now we can see that one of the IDs is missing because it's been marked 100. Now it turns out in the missing endpoint, which is another endpoint to retrieve all the 100 tags, which are nothing but missing tags. It can also get the new tags that have come into the database and also the old tags.
Thank you for watching, and do ping us for your comments for clarifications and doubts.